Excess pressure. You can understand better regarding excess pressure by studying the difference between curvature and radius of curvature. You see, curvature and radius of curvature both are inversely proportional. You go on increasing the radius, curvature will go on decreasing. For example, the radius of Earth is too high, too big. It's about 6,400 kilometer, and that radius, but ultimate result is that Earth appears almost flat. So, by increasing the radius, the curvature goes on decreasing. That means if you consider a straight line, the radius has gone to be infinite. Infinite radius means a straight line. You could say that a straight line has the infinite radius. A scientist Laplace gave an idea that whenever a surface is curved, surfaces are curved because of surface tension. Mind, you are talking about liquid surface. If the surface is curved, obviously on its one side there is going to be liquid and other side it will be exposed to the air. Laplace suggested that the difference between the pressure on either side of liquid surface will be given by 2T upon R. This is what we call Laplace relation for pressure difference. Now, just suppose, what is R? R is radius of curvature of this surface. If you consider a plane surface, obviously the radius will become infinite. Infinite, something upon infinity, what is that? It's equal to 0. So, pressure difference on either sides of a plane surface will become to be 0. That's why I have shown delta P is 0 here, surface is plane. That means above and below. Above is atmosphere, below is pressure that we are interested in. The two pressure are going to be equal here in this case, P0 equal to P. Remember, when the surface is concave, if the surface is concave, you see as shown over here, the tangential forces will result upward. That means ultimately the upward force will be greater. Pressure above the surface is going to be greater. That means you could say below the concave surface, the pressure is always less. So, obviously, the pressure here below the concave surface will be less than atmospheric pressure. So, better to write here P less than P0. You see, similarly, if the surface is concave, I have shown over here, surface is concave as explained here, the pressure will be greater below the convex surface. So, if it is P and above atmosphere, P is going to be greater than P0. Now, just suppose that there is soap bubble. Soap bubble, as already you know, has two surfaces. Two surfaces will contribute to this pressure difference. This pressure difference is also known as excess pressure, because whenever there is difference, one side pressure would be greater. That side will say that there is excess pressure, and that's given by 2T by R. But here in the case of soap bubble, since there are two surfaces, we will multiply it by 2. So, that way the pressure difference is 4T by R. You could say pressure inside the bubble is greater than atmospheric pressure by the amount 4T by R. It's shown over here. Now, if the bubble is inside a liquid quite below at a depth, suppose h depth, this depth is h, then in that case 2T by R, 2T by R would be the pressure difference because of the surface tension, and HdZ is going to be the hydrostatic pressure. So, net pressure inside this bubble is going to be greater from atmospheric pressure by the amount 2T by R plus HdG. Then concave and convex surfaces, I told you. Now, you might ask me, what is the basic reason behind this? Why the convex or why the concave surface? You see, if the surface is concave, it simply means that the liquid molecules have been pulled upward. Liquid molecules have been pulled upward by the solid molecules, and that is the effect of adhesive forces. So, when the surface is concave, you could say adhesive forces are dominating cohesive forces. Cohesive, the force between liquid molecules itself. But the force between this wall, that is solid, that is glass, and the liquid molecules, that would be adhesive. Adhesive forces are dominating and this is pulling upward. That's why it has gone concave. Similarly, if surface is convex, it means the cohesive forces are dominating and this liquid goes down, this becomes convex. You see, the example is this mercury glass, this is the example, and here you get the example water and glass. Here I have shown in which case which force is going to be dominate. Remember, when concave, adhesive forces dominate. When convex, always cohesive forces will dominate.